Last week, the 8 Nobel Prizes were awarded to several research teams. Unlike the preset categories of the Nobel Prizes like literature, economics, and peace, the 8 Nobel examines projects from the past year that demonstrate academic achievement while appearing humorous at first glance. Even though they are comedic, these studies are by no means lacking in academic rigor compared to actual Nobel Prize winners. One team this year was honored for their research into the coin-tossing theory. Erich Jan Vagemakers and colleagues from the University of Amsterdam investigated the DHM coin-tossing theory, named after the initials of researchers Diaconis, Holmes, and Montgomery, published in 2007. This theory states that the probabilities of getting heads or tails when tossing a coin are not equal, which DHM tested using machines. The Dutch team tested it manually to see if the theory matches real life. The conclusion validated the DHM theory. The probability of the coin starting and ending on the same face, like heads up before and after tossing, is 50.2%, while the opposite face is 49.8%. So while a coin has two faces and it seems intuitive that heads and tails are equally likely, the research refutes this common assumption, confirming the DHM same-side bias theory. The methodology behind this conclusion is noteworthy, since the researchers wanted to test if the DHM theory holds true in actual practice where humans toss coins manually rather than machines. They used manual testing. To properly verify a probability claim, extensive sampling is key. More trials leads to more reliable results. With variables like different tossers, coin designs, controlling for their influences is important. Vagemakers' team, including university students for a total of 48 people, used 44 different currencies and conducted 350,757 tosses over 650 hours. Each toss recorded the tosser, result, spin direction, and was filmed for verification. They also found that more experienced tosser exhibited reduced same-side bias, getting closer to an even 50-50 heads-tails split. Some would retort, why bother doing such a pointless study, judging purely by perceived utility? The shallowest consideration is what personal benefit it brings, which usually boils down to money. A slightly higher consideration is what benefit it provides to the community, often in terms of livelihood and economic interests. Even from a seemingly academic angle, people would question, what institution recognizes this kind of research? Which journal was it published in? Can this research advance the field and raise the researcher's academic standing? There is still an element of utility. Doing silly things seriously is often the greatest motivation for pursuing knowledge. What people call silly reflects our tendency to judge it as low value, which may not be entirely accurate. It could be us underestimating the issue. Someone scrutinizing this silliness is more likely driven by pure curiosity rather than self-interest. Free from external enticements, the curiosity to seek truth itself fuels more dedicated research planning and meticulous process control to arrive at the most accurate conclusions possible. To answer why bother with such a pointless study, the researchers are not idle. While Western scholars may have fewer non-academic duties, like university political conflicts, than academics elsewhere, it doesn't mean they are fundamentally leisure without research, teaching, and public service commitments. Spending 650 hours tossing coins, reviewing footage, compiling data, and writing a paper is hardly idle work. Being able to dismissively question its worthiness simply reflects the questioner's ignorance about the pursuit of truth. Marcus' research also shows that when humans are involved, there are always variables. Before learning about this study, most people would likely assume that when tossing a coin, getting heads or tails is equally probable, and they could cite probability theorems to refute opposing views. If the tosser performed as consistently as a machine, those calculations might match reality. But humans are imperfect and variable. Our performance, thoughts, even physical control have random elements. At first glance, this seems like a flaw, but from another perspective, it represents human potential. Based on calculations, we predict events will unfold in a fixed way, but introducing the human factor creates incalculable variables. It means we cannot use fixed methods to calculate our own behavior and these effects. Many examples support this logic. The whole world assuming one country would not attack another based on political ethics and geopolitics. But a dictator's mind works differently, enabling unforeseen atrocity. Or a city's existing systems, social norms, and civility face upheaval. Many worry about the future and flee, while others find reasons to persevere, quietly sowing seeds of change to what seemed an unmovable mountain. The coin toss paper's conclusion suggests the same side bias could benefit gamblers, calculating that betting $1 to win $2 a lucid draw across 1,000 tosses, while always betting on the same initial phase would yield a $19 profit. It further suggests concealing the coin's initial phase for high-stakes decisions involving tosses. Even the most rational, precisely calculated research ends up applied to the unpredictable human condition. These seemingly contradictory yet coexisting traits mirror the Ig Nobel's intent, first making you laugh, then making you think. Please comment if you have any ideas. You may also like, subscribe or share this video. Your action can spread the message. See you on the next video.